Hi, I'm Jordan Jeske, and I'm going to be demoing Lab 10, which is called Design Counters. And I have my lab Wednesdays at 12. And there are two parts to this lab, so we're going to go ahead and demo both parts. First, we're going to go ahead and demo part 1, and a little bit about part 1 is it is composed of 4 D flip-flops, and that is how the counter is the main part of the counter. And then the sequence that I'm going to go ahead and display that I was assigned is 0, 9, 11, 13, 6, 2, 4, 15, 8, and 10. And basically how we got those numbers is we use the state diagram to go from present state to next state. So for example, if the present state was 0, the next state would be 9. And then from that information, I went ahead and made a truth table for my D flip-flop inputs. And so for D flip-flop, it's pretty simple. The inputs are the same as the next state. So in that example, when it was 0, 0, 0, and the next state is going to be 9, it would be the same as 9 because that is the next state. And so basically from there, I got the truth table with the K-maps and found the minimum SOP equations. And then you use those equations to be the input for your D flip-flops. So the only input that this circuit has is the clock, and all the inputs are kind of just like a combination circuit from the outputs and different logic gates and stuff like that. So we can go ahead and start the demo, and this is with D flip-flop. So it goes 0, 9, 11, 13, 6, 2, 4, 15, 8, and 10, and then it goes back to 0. And so it just goes ahead and cycles through there. And that is the D flip-flops. No? Why doesn't it want to work?
Okay.
All right, so now we're gonna go ahead and demo part 2 of Lab 10. It's pretty similar to part 1, but the only difference is instead of using D flip-flops, we go ahead and use T flip-flops. And T flip-flops are a little trickier, but they're still pretty simple. So we use the present and the next state information that we have. And so what happens is instead of like the D flip-flop, when the next state is the same for the D flip-flop inputs, for the T flip-flop inputs, it's going to go ahead and be, if any of the 4 bits are the same, it's going to be a 0 for the input. And then if the bits differ, so the number changes, which it will, the T input's going to go ahead and be 1. And so that's how you go ahead and fill out the truth table. And then I use that to get my T flip-flops equations. And similarly to the D flip-flop, those equations were the inputs to the flip-flops. And the only input for this circuit was the clock. And then it's going to go ahead and do the same sequence. So it's going to be 0, 9, 11, 13, 6, 2, 4, 15, 8, and 10. So we can go ahead and click through it. And the only input it's going to need is the clock, which is key 0. So we can go ahead and go. So it'll be 0 is the first one. Then 9, then 11, 13, 6, 2, 4, 15, 8, and then 10. And then it goes ahead and circles back to 0.